Hey everyone, so today we have notes again. There's a lot of new definitions in here, so it's gonna seem like it's a lot of writing. But anyway, here's lesson 2.6a, identify special angles on parallel lines. Okay, so here we have parallel lines defined. So those are just coplanar lines that do not intersect. From algebra, I think in algebra you first learned that also parallel lines have the same slope. So that's something to remember. A transversal, that is a line that intersects two or more coplanar lines. And remember, coplanar just means they're on the same plane. Okay? That's all that means. Think they're on the same paper. So copy that. Pause it if you need to pause it. I'm going to move on. So here's the meat and potatoes of it. So here we have the following special angles are formed by a transversal. Okay, so again, let me check it. The line that goes through these two, this is the transversal. So I'm gonna be saying that name a lot. So I want you guys to be aware of what the transversal is. And it doesn't matter. See these lines, these parallel lines kind of run vertically, and then the transversal is horizontal. That doesn't matter. If you look at these parallel lines run horizontally, and here the transversal goes vertically. Okay? It doesn't matter. What matters is the one line that's cutting through other lines. That's the transversal. And when that happens, certain angles are formed. Okay, there's actually there's like 5 special angles. Let me go over these two first, and then I'll go over the ones on the right side. So we have alternate interior angles, and then we have same side interior angles. And this one, well, let me go over this one first. Alternate interior angles, that means they're on opposite sides of the transversal. Okay, opposite sides of the transversal, and they're interior to the other two lines. For example, let me get a pencil out. What I like to do, what I tell the kids is see how these two lines, imagine you connect these like this, right? And then you have an inside the circle and outside the circle. So alternate interior are angles that are inside, okay? And they're alternate. Alternate means they're on opposite sides of the transversal. So I'm going to put an example. Let's say angle 1, actually 1, 2, let me call this one 3, 4, 5, and 6. I'm going to name these angles 3, 4, 5, and 6. 3 and 6 are alternate interior. They're on alternate sides of the transversal, but they're interior to these other two lines. So angle 3 and angle 6, those are alternate interior, and so are 4 and 5. They're interior to the two lines, but they alternate across the transversal. So alternate interior. So that's also angle 4 and angle 5. Okay. And then same side interior, well, that pretty much means they're on the same side and they're interior. The same side of the transversal and they're inside. So that's 3 and 5. Angle 3 and angle 5 are same side interior. And move that up a little. And then the other pair would be 4 and 6. They're on the same side of the transversal, and they're interior to here, to the circle, interior to the two lines. Angle 4 and angle 6. Now this one sometimes has a different name. I personally like same side interior because to me that makes sense. But our book sometimes uses this. Well, our book uses this term. So sometimes, depending on your geometry book, consecutive interior. That's the name I believe this book uses. I don't like that name. Okay, so I just may call it same side interior. And if I see it as consecutive interior anywhere, I'll try to remind you guys, hey, that's just same side interior. Okay. So that's these two. Let's look at these two over here. So then, instead of alternate interior angles, we have alternate exterior angles. And instead of same side interior angles, over here it's same side exterior angles. So the definition is going to be a little bit the same. So if you read these definitions, you can see how they're similar, and that's kind of why I put them side by side. Okay, but anyway, these angles would be 1, 2, 3, 4, 5, 6, 7, and 8. Okay, and again, if you think what I tell my students, if we connect this and make it into a big I don't even know what you'd call this, oval shape. There's an inside. I call this inside or interior. And then there's exterior. This is the outside, right? All of these were interior. That's why we have alternate interior, same side interior, right? And then over here, these are exterior. It's not interior, it's got to be exterior. It's like inside, outside. Okay? And then, so alternate exterior means they're on they're opposite sides. So think 1 and 8. These are on opposite sides. See, one's on the left side, one's on the right side. Those are opposites. And it's exterior. So they alternate and they're exterior. So that would be angle 1 and angle 8. And then another pair is 2 and 7. They're exterior and they're alternating. It's jumping from the right side to the left side of the transversal. So angle 2 and angle 8. Alternate exterior. Alternate means they're jumping from one side to the other side of the transversal. See, I put 1 and 8. 8 is on the right side and 1 is on the left side. Over here, 2 is on the right side, 7 is on the left side. I wrote that wrong, huh? You guys weren't going to tell me? I'm joking. So 2 and 7. 2 and 7 are alternate exterior, and then 1 and 8. That's a 7. Let me write that a little bit better. I don't like that. See, now this video is going to be long because of that. Okay, 2 and 7. And then same side exterior. Again, they're on the same side of the transversal, but they're exterior to the two lines. So 2 and 8 are same side exterior. And then the other side would be 1 and 7. 1 and 7 are both on the left side of the transversal, but they're exterior to the other two angles. Okay. So those are 4 of the new terms. And then we have, so if you need to pause this and then write it. And then we have this one here, corresponding angles. Okay, I know you can't see that. Let me lower it a little bit so you guys can get the definition. Corresponding angles, they lie in corresponding positions, meaning like they're in the same spot. Okay, they're in the same position. Because I like to go back. I always like to go back to our angles that are like this, right? Now imagine if you just like let's say this is angle 1. Okay, so that's over here. Imagine you drew another X over here. right? And call this angle 5, I don't know. 5 and 1 are in the same spot. Okay. But if you make this vertical or parallel lines, so then 1 and 5 would be corresponding angles because they're kind of in the same spot of this original X. So for corresponding angles, there's a whole bunch of corresponding angles up here. And I don't have any written down, but let me fill in the angles in here more. If I put them all in here, 1, 2, 3, 4, 5, 6, 7, and 8, there's a bunch of different corresponding angles that we can come up with. The only ones, I'm just going to come up with 2 pairs. So if we look at angle 1 and 5, those are corresponding because, again, if you look at angle 1, let's say if I'm looking at just this part, angle 1 is in the top left corner, okay, of this cross. So if we look at the bottom one, if we look at this cross, 5 is in the top left corner. Okay, they're in corresponding positions, top left. So that would be angle 1 and angle 5. And actually there's a whole bunch of them in there. I'll do one more. So again, let's look at the top part. Let's go with angle 2. Angle 2's, well, let's take a bottom one. Angle 4. Angle 4 is in the bottom right. Okay? Bottom right. So then if we look over here at this one, this is the top, this is the bottom. 8 is in the bottom right. So 4 and 8 are in corresponding positions. So that means they're corresponding angles. Whoa, 12 minutes. Okay, so again, pause that if you need to pause it. I'm going to stop for a minute. Let's do the examples. So copy this. Let me stop moving it so dang much. Stop moving it, Rocha. Okay. So the examples isn't too much. Maybe I should have wrote this up here. I could have. But classify the pairs of angles. So here we have our little diagram with all the angles in there. And then we're going to say, okay, what's 1 and 8? What's 4 and 6? What's 3 and 6? All of that. Okay, so pause it, copy it, and then I'm going to go over it. Okay, so here's all of the angles. You guys can see these. And again, what I like to do, I'm going to close these in. Okay, and this is my interior. And I mean, I technically don't need to write that that's the exterior, but this is exterior, and this is exterior. Okay. So then if you look at 1 and 8, here's 1 and 8. 1 and 8 are both in the exterior. Okay. And they're on, 1 is on the left side of the transversal. I should have put that also. This is the transversal. 1 is on the left side, 8 is on the right side. So these are alternating sides, and they're exterior. Alternate exterior angles. Okay, they alternate from left to right, and they're both exterior. So alternate exterior angles. Okay. Oh, that's not. Let me try to make it a little bit bigger. Hopefully you guys can see that. Okay, so let's go with angles 4 and 6. So 4 and 6, if you look at 4 and 6, they're both interior, and they're on the same side of the transversal. 4 is on the right side, 6 is on the right side. So this guy would be same side, interior angles. Okay, they're on the same side of the transversal and they're interior. Too bad this one isn't like opposite exterior because they're on opposite sides. Anyway, 3 and 6. If you look at 3 and 6, 3 is interior, 6 is interior, so I know it's interior. And then 3 is on the left side, 6 is on the right side, so those are opposite, so that's going to be alternate interior angles. Okay. And then I threw in some from before, some that we've done before. Angle 1 and 2. This is on a line. 1 and 2 are next to each other. That's a linear pair. This is from before. Okay, linear pair. Don't forget what we've already gone over also. Okay. Let's do 3 and 7. 3 and 7, if you look at 3 and 7, see 3 is interior, 7 is exterior. Whenever it's like that, whenever it's interior, exterior, you should automatically think corresponding, because corresponding angles isn't interior or exterior. So 3 and 7 are corresponding angles, and I'll show you in a minute why. Corresponding angles. So remember, corresponding angles means they're on the same corresponding position. So if you look at 3, let's look at the X up here in 3. I would call this the bottom left, because it's below this one and to the left of the line. So that's 3. Then if you look at 7, again, if you look at 7 in relationship to this X, it's in the bottom and it's on the left side. So 3 and 7 are both on the bottom left, so they're in the same position. So that's called corresponding angles. Same position angles would have been a better name. And then 1 and 4. Again, don't forget about 1 and 4. 1 and 4 are vertical. That's our old school vertical angles. Old school. It was like from 2 weeks ago. This one's an older one. Okay. And that's it. Yeah, the notes are long today. There's a lot of explaining though. Okay. So let's do the assignment.